And what this entails is no more graph. You're going to be okay without graph paper. All right? What's going to happen is that you are going to be graphing, and as we build into these things, you are going to be graphing and finding these shaded regions. You're going to be able to figure out and plot that, you know, on some of those are stuff from last night you guys made a triangle, or you found that rectangular looking space. You're going to be able to find and figure out all the different ordered pairs that make up the vertices of these shapes. You're going to be able to do that and then be able to use them to find maximum and minimum values given a specific constraint function. What this means is that first thing we have to be able to do is graph in inequalities to find their vertices of a shape, if you will. Then I'll introduce what it means to be a constraint and then how it goes from there. It's really using everything we've done so far in chapter 3 all in one section. Tomorrow we take it a step further, we put it all together with words. So with this problem here, when I look at it, I've got x is greater than or equal to 0, y is greater than or equal to 0, negative x plus 3y is less than or equal to 15, and 2x plus y is less than or equal to 12. From just those 4 constraints, can we tell what quadrant this is going to lie in to start with?
Yes. Right.
Top right, otherwise known as
First.
quadrant 1. Very good. So I know this is a first quadrant problem to start with. X is greater than 0 goes that direction. Y is greater than 0 goes this direction. I'm just marking those on my paper with some arrows to show which way it's going to be shaded. Okay? The x and y axis right here is bounded me to that first quadrant. Now, I can use quick graphs to figure everything else out. If I want to figure out what my y-intercept is for the second one, I cover up x, and what do you get for your y-intercept? Good, so I know it's at 5. 0, 5. And what's your x-intercept? Negative 15. So this one kind of stinks because it's a negative, but it's no big deal. Because I'm not worried about the graph being over this direction, but once I get past here, my graph is this way. Okay? So I really don't care about the graph to the left of 0. That's why I just kind of made it dotted. I just know that from this point on, it's still increasing and going to the right. Now I have to figure out how to shade that. So, do I go through the origin? No. No. What's 0 plus 0?
0.
Is it smaller than 15?
Yes.
Yes. So I know it's going this direction. Okay? So as of right now, I've got this bounded region that's in here. Okay? As of right now, I've got a bounded region in there. I go to my next set of intercepts. Do you guys agree it's at 6 and 12? Or, yeah, 6 and 12. 6 for x, 12 for y. Okay. So 6, 0, and 0, 12. What's 0 plus 0? Is it smaller than 12? Okay. So as of right now, we have this boundary that we found of a four-sided figure. Okay? On that four-sided figure, right now we know 2 of their points of where it changes directions. There was a set of the some of the ordered pairs on the axes. We know the third one because what's this point here?
0.
Correct. It happens to be at the origin. Now, what we do in order to figure out what the third or the last point winds up being is that in order to figure out where the 2 lines intersect, remember when we did linear combination stuff in section 3.2 last week? Solving systems. We go back and we solve the systems of equations. Now, what we've talked about a lot today is that everybody sees how these 2 are written out as inequalities right now.
Yeah.
When you go to solve the systems of equations to figure out what is the ordered pair where those 2 intersect, treat them as an equal sign. don't worry that it says don't worry it says less than or equal to or greater than. Just use it as equal. So what you're doing then is you're setting up, was this negative x plus 3y is 15, and 2x plus y is 12. You solve that system to find out that intersection, that ordered pair where they meet. You can substitute, or in this case, do you see how I have alternating signs right away with the x values? I'm going to multiply the top one by 2 and rewrite it below the second one. So I get negative 2x plus 6y is 30. So then when you have same coefficient, opposite sign, how do you get rid of them? Good. 7y is 42. Y equals 6. So I know the ordered pair is going to be something, comma 6. Yes, sir?
That's 3.
Correct. And then to figure out the x value, all we do is go back and you substitute back, just like we did last week. So you're using the same skills that we did last week with the solving systems, getting the ordered pairs where they match up, where they intersect with one another. And right now, you have now found 4 ordered pairs with change direction of that quadrilateral boundary, or polygon boundary, I should say. Yes, sir? I can read it to you. When you're trying to maximize or minimize profits and stuff like that, that's what we do. If you want to make a gift basket for your mom who's an avid reader, you decide to include hardcover books and paperback books in the basket. You have $80 to spend. Each hardcover is $24 and each paperback is $8. The basket will hold at most 3 hardcover or 7 paperbacks. Find the maximum number of books you can buy. That's what we start with tomorrow.
Hard to buy. Who buy that?
How about I buy her a Kindle and I don't have to solve it?
All right, money bags. So what we do then is the next step of this is to introduce you guys to what is called the objective function. After you're able to figure out those 3, 4, 5 points at which the intersections occur, where it changes direction in the on the graph itself, what you do is you got those ordered pairs, but you got to figure out, well, what do I do with that information? That information is going to be used with what's going to be given to you as an objective function. Today, all of your objective functions will be given to you. All of your homework problems will have this equation that says C equals something. In this case, the first one is C equals 3x plus 4y. So what happens is after you find out all of your ordered pairs, you substitute your ordered pairs into that objective function, figure out which gives you the biggest number, which one gives you the smallest number, hence maximum, minimum. When it comes to the word problem stuff tomorrow, you will have to figure out the objective function. It doesn't take very long to figure those out after we do a few of them together. So I know you guys are going to whine and complain all day long, like, oh, I don't want to do the word problem. Ladies and gentlemen, word problems become more and more prevalent starting tomorrow. So we're going to have to get over the phobia real fast. Okay? So this is the way that the book writes these things out, subject to the following constraints. X is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than or equal to 8. First thing you got to do, graph it. Where is this line? First quadrant, you're right, it's going to look like a triangle. It's first quadrant, because x is greater than or equal to 0, y is greater than or equal to 0. And after that, we have x plus y is 8. What are your intercepts? 8 and 8. Bless you. Bless you. And then you have to test point it?
No.
No, you don't want to test point?
Yes. Wait.
Well, 0 plus 0 is
Well, I thought you were talking about-
It's true. Yes.
Yeah.
It's in here. So I have to use 0, 0. So does everybody agree that right now I have 3 ordered pairs where it changed directions? 0, 0, 8, 0, and 0, 8.
I think so.
It doesn't matter which order I check these in, but I'm going to use this objective function with the ordered pairs 0, 8, 0, 0, and 8, 0. All I'm doing is substituting in x and y. I hear see timeout. What do you got?
Wait, what's happening right now?
All I'm doing is taking those 3 ordered pairs where they change, where the boundaries are set,
Okay.
and I'm using those are going to be my points to check the objective function.
And the objective function is the C.
Yes, the objective function is the C. C equals whatever. Some way that'll be different each time. Yes, ma'am.
Do you just have to like write out that, or do you have to actually solve?
Oh yeah, I'm not done. So I was asking. Now the last bit here is I get what's that? 32, 0, and 24. Where did your maximum occur?
32.
0.
0, 8. Thank you. I'm glad you said it that way, not just 32. Remember, the maximum is occurring at that ordered pair. Like tomorrow, when we talk about the books, the maximum value you could have had, it could have been 7 hardcovers in 1 paperback, or something like that. That's the kind of stuff you're looking at. You're looking to answer it as an ordered pair. There's bakery questions. There's lots of stuff. And then your minimum value, obviously, is at 0, 0. Okay? Yes, sir?
Do you even know what the meaning of bakery is?
I really have that discussion with you like this every single day. You don't need to act like this, all right? You don't need to act like that. It's really old. Other people really are trying to figure out this stuff, and then you come out of here with some other BS thing. We don't need to know it, okay? It's not prevalent what we're talking about, okay? And so on. Same idea. It doesn't change. It doesn't change. What's going to happen a lot of times now, you're also going to get more and more things that will be written to you as horizontal and vertical lines. You have to remember, what does that mean? X equals a number, Y equals a number. What direction are they going? Things like that. When you have X that is greater than or equal to 2, is that a horizontal or a vertical line? Vertical, thank you. What number does it go through? 2, okay? So you just start with a rough sketch again. Draw on a little grid. You know you have a vertical line through 2. And it said X is greater than or equal to that. So it means it's got to be pointing towards the right. So if you forgot or didn't know where to start, you always start with a grid. Start with a grid and then go to the next statement. After that, we know it's less than or equal to 5. So right now, I have this boundary between 2 and 5, including 2 and 5. No top, no bottom to it. So right now, without a top and a bottom, I'm not going to have any maximum values or any minimum values because there's nothing to stop it. The next one says I have a basement, if you will. Y is greater than or equal to 0. So I know that it's got to be coming up from here. Okay? I now have a bottom to it. So if you want, you can always just do this to get rid of it. So you don't have to worry about looking down there for any intersections later. You don't have to. And then lastly, it's written in slope-intercept form, but could you figure out your intercepts anyway? What's your y-intercept? 12. Your y-intercept is 12. I heard someone start to say it. What's the x-intercept? 6. Very good. In order to figure out your x-intercept, just set y equal to 0, move the 12 and divide by -2. Now it becomes interesting. Is 0 smaller than 12? It is. So it's shaded into this, once again, this four-sided figure in here. All right. We know for certain two of the ordered pairs without too much of a hassle. 2, 0, and 5, 0. Move the 6 over here. You guys okay with that? Now to figure out the other sets of ordered pairs, use properties of vertical, and sometimes we'll use properties of horizontal lines, knowing that what's the x coordinate going to be there? 2. What's the x coordinate going to be here? 5. Now to figure out the y values, all you got to do is substitute in. Because you know what x was. X has got to be 2. So 2 times -2 is -4. -4 and 12 is how much? We're still losing me. The eyes just rolled in the back of your head. You all right, man?
Yeah.
And then I do the exact same thing with the 5. And what do I have? Yeah, 5, 2. You'll get the same thing to walk the slope if you want, but I mean, you don't have to worry about graph paper. This is just as quick. When you have horizontal vertical, it's just quick substitution. Yes, ma'am. The x-intercept. Remember, the x-intercept is when y equals 0. So what I did is I set y equal to 0, and I solved for x. I subtracted 12, and I divide by -2. That's how I got 6. It's a little bit different than the cover and solve. It was cover and solve without x and y at the same side. Yes, sir?
What exactly is -x plus 3y? Like, I mean, what is the c, what is that equation?
The c value, remember, the objective function is what are you trying to maximize or minimize. And all we're doing today is practicing with what they give us. Tomorrow it's going to be maximizing profit, minimizing man hours, things like that.
What are they giving us? Like,
It's not
is
giving-
this an equation, and does it go to the graph? Does it, what is it doing?
It's something to deal with the problem. And today it's tough to see how that is, but tomorrow when you see how it works with the word problems, it's a lot clearer. The objective function today is nothing more than use this, find the biggest value, find the smallest value. That's all I want you to think about with it for today. Tomorrow, it's going to be, I want to maximize profit. Okay, how do I create a profit? Well, I earned $4 for selling pencils, $3 for selling chairs. So it'll be 4 times P plus 3 times C is my overall objective function. And C was a bad choice because I have C up here instead of J. But you see what I'm talking about. So we'll get into that more tomorrow. It's going to be a lot clearer where that objective function is brought from once we get into the word problem. Today it's going to say, here's the objective function, and use it. All right. So now you've got your 4 ordered pairs. What do we have? 2, 0. This came up earlier today. Does it matter what order I use to write these out? It really doesn't make a difference. Was it 2 and 8? So. And you just fill out which one's the largest and which one's the smallest. In this case, it just asks for the maximum, so it doesn't even matter if you don't have to label out the minimum. The maximum, I'm going to go out on a limb, is going to occur at 2.8. I believe you get 22?
Yep.
And sometimes it's going to be that obvious as you go through them. Plus, if you look at your graph, depending upon how the graph sets up, a lot of times some of the larger values on the graph give you your maximums and minimums.
You need to finish it then if you already know. Like if it's asking what's the max value of this, you gotta you already know the point, you can just say that's your answer.
That can be it, but just be careful. Sometimes the objective function's funky. In this case, it worked out real nice because as we wrote it out, we know it's not going to. Everything else is going to be smaller than that one. So just be careful as you do that in there. Yes, sir.
There's some that says maximum value of, but we have some that say minimum
Yes.
value of. Would
I-
some say both?
I think the ones you're doing tonight are all max and.
So say maximum and minimum value.
Yeah, the ones that we're doing tonight would all be max min. I was just kind of showing you how it can look. Okay. So just keep on. Terrible?
No, it's just like many steps.
Yeah, but you see how it's just a mix of everything we've done.
My brain is vegetable.
So this is how you maximize like man hours, so you like an employer can like
Yeah.
determine what the
Yep.
workday should look like.
Yep. Yep, it's a lot of that when you look at things of it's one of the things you can do to maximize your man hours. Another thing, you always look at your sales figures. You look at sales figures between different hours. If you're at a retail store, your sales, depending upon like what kind of a store, if you're like a Home Depot or Lowe's or something like that, during the week you have hard sell in the morning for contractors, and then you have a more of a sell later in the afternoons and evenings for people cut off to work. On weekends, you're just loaded. You know, it's much busier, but you're not as busy at like 2 o'clock in the afternoon on a Tuesday. So you wouldn't be as staffed as heavy on a 2 o'clock in the afternoon on a Tuesday because you have sales supporting that. You don't need that many people, but you need more people in the morning to help out with contractors. You play into a lot of different things, but yes, this is one of those things you can use.
And they give you you can only use like 2 lines really, or you can only graph like really like 2 lines because these 2 are at like 0.
Well, it depends on the problem. A lot of the word problems that we do, I think the most lines that we have, I think maybe 4. But that just means you're starting, instead of starting at 0, you're starting at like 3. It says like no less than 3, but no more than 20. So it's between 3 and 20, something like that. So,
Alright, and how do they determine like the min and max equation?
oh, we'll get to that tomorrow.
Okay.
Because you have to know more specifics if you want to maximize your profit, if you want to maximize labor. It's problem dependent. Today, here it is, figure it out. So you don't have to worry about that.
Alright.
So try to set this one up, and we'll see how we do here in a second. Move this over so we can pause it real quick. Lots of same questions. So I know x is greater than or equal to 0, so it's everything to the right. That's why I drew out those 2 lines. After that, I know that y is less than or equal to 2x plus 2. Means I have a y-intercept of 2, and I have an x-intercept of -1. So it's going this direction. Okay? From that, I don't care about anything going to the left of the axis, but I have to check, is 0 smaller than 2? Yeah, so it's going down this way. Okay? It's stopping me, this first statement is stopping me from going anywhere x less than 0. Okay? And then the next one, it has x and y intercepts at 5. And it's coming inward in here. So we have to figure out where those 2 lines intersect. Remember, where 2 lines intersect is how you solve the system of equations, what we did last week. You take the 2 lines, you take their equations of those 2 lines. Y equals 2x plus 2. 5 equals x plus y. And you solve the system. There are linear combinations, substitutions, multiple ways of going about it. This problem sets you up for a substitution right away. Because it says y is 2x plus 2. Everybody see that? So 5 is x plus 2x plus 2. All I did was substitute in here and here. Move the 2. I get x is 1. Yes, sir.
How do you know how low you can go? You know how you know like x?
Yeah.
How far down?
It's a good question. Am I bounded at the bottom?
No.
Correct.
That's why I'm confused,
Because this continues, doesn't it? Is there any bottom to this? Is there any stopping to it? No, does it? So is there going to be a minimum value? No.
There's going to be max.
There's a maximum. In this case here, since there's no boundary to stop you, there's no minimum. But what happens is, you have an ordered pair up here that's 1 and 4, because 1 plus something is 5, 4. What happens is, if you follow your points that change direction, it's just those 2 points at 1, 4, and then at 0, 2. Those are the only 2 points that the graph changes direction. Everything else, it just drops on down. And there's no basement. There's nothing there. So there's not going to be a minimum. Yes, ma'am? That's where those 2 lines intersected. I solved the system of equations. I got 1 for x. 1 plus y is 5. Y is 4. Okay? So I have the ordered pairs. Now, I just have to figure out then, where's my maximum? Because the minimum doesn't occur. There's no minimum here. Because there's no basement. This could also happen if there's no ceiling. It could be no maximum. Okay? You can have no maximum by it just being spun around. So all you do is take those 2 ordered pairs. Is it 0 plus 5 times 2? Or is it 1 plus 5 times 4 to give you your maximum? Yes, sir?
Why did you have to solve it? Why didn't you just like quick graph it? You have to do all that.
I did quick graph everything, but I had to figure out where these 2 points, where those 2 lines intersected. That's what I had to solve for. I didn't solve anything else but that. It's the only thing I solved for, is the intersection point of those 2 equations.
Oh, okay, I see.
All right, that's all I had to do was find the intersection of those 2 points. This is nothing more than what we have done in the past. It's blending graphing with the algebra. That's all we're doing, blending graphing and algebra together. There's one other one I want to, this one. Which one is it? Yeah, we'll call it on this then. Here's what I want you to start on for tonight.
Should we use that graph paper?
Don't use graph paper. Just do those. Rough sketch them.
Are they all like a problem? Like what do you solve?
They're going to look, I'll show you here, let me pause, let me stop this and let it compile, and I will show you exactly.